Imagine two individuals strolling past one another on an empty street, one moving toward the east, the other toward the west. There's absolutely nothing remarkable about this scene whatsoever. Now reimagine that identical moment, but this time think about what's unfolding 2.5 million light years away in the distant Andromeda galaxy. Based on our most refined comprehension of physics, these two individuals crossing paths on that sidewalk, traveling at nothing more than a casual walking pace, might disagree about what's occurring right now in Andromeda by as much as several complete days. Not what they're capable of observing, not what they're able to measure, but what they would define as the present moment. Multiple days of disagreement generated simply by moving in opposite directions at walking speed. This notion sounds completely ridiculous, like some kind of error or illusion or fundamental misunderstanding about the basic nature of time itself. But it's none of those things whatsoever. Special relativity communicates precisely this concept to us, and it's been validated through extraordinarily precise testing for more than 100 years now. That's the subject we're diving into today. We're about to examine one of the most peculiar and most unsettling concepts in the entire field of physics: the genuine possibility that the future has already come into existence, that your tomorrow possesses the same degree of reality as your yesterday, and that the progression of time itself might be something dramatically different from what you've perpetually assumed it to be. This concept is known as the block universe, and certain physicists and philosophers refer to it as eternalism. If this turns out to be an accurate representation of reality, then the manner in which you experience time, that sensation of the present moment flowing forward into an open and undetermined future, isn't quite what it appears to be. Let me be transparent from the very beginning. This represents one of those subjects where the physics itself is solid and thoroughly tested, but the philosophical implications remain actively debated among experts. And I'll make clear distinctions between what the mathematical equations tell us with absolute confidence and what remains a matter of interpretation and perspective. The objective here isn't to persuade you that any particular viewpoint is definitively correct, but rather to demonstrate why serious physicists take these concepts seriously and what the implications would be if they turn out to be true. If you find yourself drawn to this kind of profound exploration, if you value taking the necessary time to genuinely sit with ideas that fundamentally challenge how you comprehend reality, I'd encourage you to subscribe to the channel because it helps these explorations reach more curious minds like yours and signals to me that this is precisely the kind of content you want to encounter more of. So now, let's dive in and begin this journey. Before we can properly understand why physicists discuss time in such extraordinarily strange ways, we need to comprehend what time meant before Einstein arrived on the scene. What absolutely everyone assumed was self-evident and obvious, and why his revolutionary work completely shattered that assumption into pieces. For the vast majority of human history, stretching back thousands of years, time appeared to be the most straightforward thing imaginable, flowing steadily from past toward future in an uninterrupted stream. The present moment was real and happening right now. The future hadn't yet arrived. These concepts weren't even ideas that required explicit stating. Because they were so profoundly obvious, they barely even qualified as beliefs or assumptions. Isaac Newton's groundbreaking Principia, published in 1687, formalized the fundamental laws of motion and gravity, with these intuitions built directly into the foundations, treating time as something absolute and flowing uniformly everywhere throughout the universe at precisely the same rate for everyone without exception. If it's 3 p.m. right here, it's 3 p.m. absolutely everywhere in the cosmos. The present moment was understood to be universal, and this matched our everyday lived experience completely and perfectly. You and I might disagree about countless things in life, but we wouldn't disagree about whether something is happening in the present moment, or in the past, or in the future, because those categories seemed as genuinely real and as fixed as the physical objects surrounding us in space. For well over 2 full centuries, this framework served as the absolute bedrock of physics and scientific understanding. Time was simply time. Simple, universal, absolute, and unchanging. That entire worldview changed dramatically in 1905. Albert Einstein, just 26 years old, and working as a patent clerk in Switzerland, published a paper that would eventually and fundamentally transform how we understand reality itself, introducing what we now call special relativity with a profound revelation buried within its mathematics that challenges absolutely everything we think we know about the nature of time. The core of Einstein's brilliant insight came from thinking extremely carefully about one deceptively simple fact. The speed of light in a vacuum is always precisely the same, never varying in the slightest, regardless of how fast you happen to be moving or how fast the light source itself is moving. 299 than 792,458 meters per second, or roughly 608 through 616 1929 miles per hour, never changing or varying under any circumstances. This might not sound particularly revolutionary on the surface, but think carefully about what it actually means in practice. Standing perfectly still, holding a flashlight, the light travels away from you at exactly 209,792,458 meters per second, which makes complete intuitive sense. Now imagine yourself aboard a spaceship traveling at precisely half the speed of light, turning on that same flashlight while pointing it in the direction you're traveling. Common sense and everyday intuition say the light should now be traveling at 1.5 times the speed of light relative to any stationary observer. Your speed plus the light's speed combined together. That's not what actually happens in reality though. The light still travels at exactly the speed of light, no more and no less. Not 1.5 times that speed, just precisely the speed of light. Exactly the same as before, unchanged. This completely violates everything our deep intuitions tell us about how velocities should add together in our everyday experience. And when Einstein meticulously worked through all the mathematics of what this constant, invariant speed of light genuinely means for physics, he discovered something that absolutely shattered the entire Newtonian picture of time that had stood for centuries. Simultaneity turns out to be relative rather than absolute. Let me take some time to explain what that means in detail, because it's the key to absolutely everything that follows in this discussion. Simultaneous appears simple and straightforward in our everyday lived experience, with two events happening at the same time being simultaneous. End of story. Case closed. Einstein's equations revealed this isn't quite right though, because two events that appear perfectly simultaneous to one observer may not appear simultaneous whatsoever to another observer moving relative to the first observer. The mathematics is extremely precise about this phenomenon, with a formula called the Lorentz transformation, describing exactly and specifically how observers in relative motion will disagree about precisely when events occur in time. For two events separated by some distance in space, the difference in how two different observers assign times to those events is approximately equal to their relative velocity multiplied by the distance between the events, all divided by the speed of light squared. This formula has been tested countless thousands of times in numerous experiments and forms the absolute basis of particle physics, GPS satellite systems, and countless modern technologies we rely on daily. The mathematics works flawlessly, and the question at this point isn't whether it's correct, but rather what it actually means for our understanding of reality. That's precisely where things start to get genuinely strange and counterintuitive. Picture two observers moving past each other at a modest, unremarkable speed. Nothing particularly dramatic, just one person walking east and another walking west, with their relative speed approximately 1 meter per second, which is around 2 miles per hour. Across ordinary everyday distances, like a room or a building, the difference in their simultaneity assignments is completely negligible, with agreement to within a tiny fraction of a nanosecond if they're attempting to determine what's happening right now on the other side of the room from them. We never notice this effect whatsoever in daily life because the effect is far too microscopically small to detect with our senses, or even with most instruments. The formula clearly says the disagreement grows proportionally with distance though. With the farther apart the events are in space, the larger the disagreement becomes in time. Let's take this principle to an extreme example to really illustrate the point. Approximately 2.5 million light-years separates us from the Andromeda galaxy, which translates mathematically to approximately 2.365 times 10 to the 22nd power meters, or roughly 1.47 times 10 to the 19th power miles. Now, carefully consider our two observers walking past each other at just 1 meter per second in opposite directions. Nothing unusual or dramatic about their motion. When they both look toward Andromeda and independently ask the question, what is happening there right now at this very moment? The rigorous mathematics of special relativity says they will fundamentally disagree with each other, not by nanoseconds or microseconds, not even by minutes or hours, but by approximately 3.005 complete days. If one of them declares, right now in Andromeda at this very moment, it's Tuesday, the other one, because of nothing more than their slow relative motion at walking speed, would declare with equal validity, right now in Andromeda at this very moment, it's Friday. Here's the deeply uncomfortable part that's hard to accept. Neither of them is wrong or making any kind of error. According to special relativity, there exists no fact of the matter whatsoever about which one is correct or incorrect. Simultaneity at these great cosmic distances is not an objective feature of reality carved into the fabric of the universe, but depends entirely and completely on your state of motion relative to the events in question. This result is sometimes called the Andromeda Paradox, and it's been popularized as an extremely vivid illustration of what the relativity of simultaneity genuinely means when you take it seriously and think through its implications. Pause for a long moment and genuinely try to absorb and internalize this concept fully. Two people walking slowly past each other at ordinary walking speed, disagreeing by multiple complete days about what is happening right now in another galaxy millions of light years away, with neither of them making any mistake or error whatsoever, because the disagreement is built directly into the fundamental structure of space-time itself at the deepest level. I vividly remember the first time I truly understood this concept on a deep level, and I had to physically put down the book I was reading and just sit with it in silence for quite a while, letting it sink in. If this is genuinely true, if simultaneity really is relative in precisely this way, then the present moment is fundamentally not what we think it is, and now is not carved into the fabric of reality as an objective feature, but is actually perspective-dependent and observer-dependent, somewhat like the direction you might call forward or to the right, which varies depending on your orientation. And that realization has profound consequences for how we understand reality. Now let's discuss in detail what this means for the fundamental nature of time itself and our place within it. The year 1908 brought a mathematician named Hermann Minkowski into the picture, taking Einstein's revolutionary equations and reframing them in an entirely new conceptual way. Just 3 short years after special relativity's initial publication, Minkowski demonstrated something remarkable: that space and time, which we usually think of as completely separate and distinct things, can actually be combined into a single unified 4-dimensional structure that he called space-time. In this radically new picture, the universe is not 3-dimensional space that happens to change over time, but rather a 4-dimensional space-time continuum, with what we call time simply being one of the dimensions, genuinely no more special or privileged than the 3 dimensions of space we're familiar with. An event in your life is not something that happens and then vanishes completely into the past, never to exist again, but rather is a point in space-time with specific coordinates in this 4-dimensional structure. And that point is just as real, just as existent, as any other point anywhere in the structure. Your birth sits at one particular set of coordinates. Your reading of this sentence right now sits at another completely different set of coordinates. And both of those points exist within the 4-dimensional structure simultaneously and equally. When Minkowski first introduced this revolutionary framework to the world, he made an extremely striking statement about it that's worth quoting. He said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality. Space and time as separate, independent concepts are merely shadows of something deeper. And the real thing, the fundamental reality, is the unified structure we call space-time." In this 4-dimensional picture that Minkowski developed, your entire life from beginning to end is what's called a world line, which is essentially a thread that traces through space-time from your birth coordinates all the way to your death coordinates, with absolutely every single moment of your existence located somewhere along that continuous thread. The thread doesn't move or flow through space-time in any meaningful sense, but simply exists within it as a static, permanent feature. This way of thinking about reality is called the block universe, or sometimes eternalism by philosophers. All of space-time exists together in one unified structure, like a solid block of 4-dimensional existence. Past events are not gone or disappeared, while future events are not non-existent or yet to be created, since they're all there simultaneously at their respective locations in the block, existing together. What we subjectively experience as the passage of time, in this revolutionary view, is something analogous to moving through a landscape, with the landscape itself not changing at all, while you simply find yourself at different points in it as you move through it. Different points along your world line correspond to different conscious experiences that you have, and you experience those in sequence as you move along the line. But the entire sequence exists all at once, simultaneously, within the four-dimensional structure, spread out like a map. This is a genuinely radical idea, and many people find it deeply and profoundly counterintuitive when they first encounter it. But here's exactly why serious physicists take it extremely seriously and don't dismiss it. The relativity of simultaneity that we just discussed seems to push us strongly toward accepting it as our model of reality. The argument was made explicit and formally developed by philosopher C. W. Reitdijk in 1966 and Hilary Putnam in 1967. And it starts with one deceptively simple question that has profound implications. What exists right now at this very moment? If you're a presentist in your philosophical outlook, you believe that only the present moment exists in any meaningful sense, with the past having ceased to exist entirely, and the future not existing yet in any way. Reality becomes a kind of moving spotlight that illuminates only the present moment, while absolutely everything else sits in complete darkness, non-existent. This is how most people naturally and intuitively think about time, without even realizing they're making philosophical assumptions. The past is gone and no longer exists. The future hasn't happened yet and doesn't exist. Only now, only this present moment is real and existent. Think carefully about what the relativity of simultaneity means for this intuitive view, though, and you'll see the problem it creates. Picture an event happening somewhere in Andromeda Galaxy right now. Call it Event A for simplicity. Right now, as you sit here reading this, there exists some observer somewhere in the universe moving relative to you at some velocity for whom Event A is in their past, already happened, and completely done and finished. According to their frame of reference, which is just as valid as yours, Event A is a settled fact of history, no longer subject to change or uncertainty in any way. From your perspective, though, using your frame of reference, Event A might be in your future, not having happened yet from your point of view at all. The key philosophical question that arises is this: is Event A real or not? If you're a presentist believing only the present exists, you might be tempted to say Event A isn't real for you because it's in your future and hasn't happened yet. Another observer, though, equally valid and legitimate according to all the laws of physics, says Event A is absolutely real because it's in their past and has already occurred. The Reitdijk-Putnam argument holds that both observers must necessarily be describing the same single reality, since there's only one universe after all, not separate universes for each observer. If Event A is real according to one legitimate observer, and that observer is just as legitimate and valid as you are, then Event A must simply be real, period, full stop. The argument continues and deepens. If any event that is past for some legitimate observer is real and existent, and if there are legitimate observers moving at various velocities for whom almost any distant event you can imagine is in the past, then distant events must be real, regardless of whether they're in our past, our present, or our future. The relativity of simultaneity seems to force us inexorably toward eternalism and the block universe view. And if you genuinely can't draw an objective line between now and not now that all observers agree on, then the distinction may not correspond to any difference in what actually exists in reality. I want to be extremely careful here, because this argument has been vigorously debated by philosophers for many decades and is not universally accepted by any means. There are sophisticated responses and critiques, and the year 2021 brought Yaron Sheffer publishing a detailed critical analysis of the Andromeda Paradox, arguing that the usual metaphysical takeaway isn't as straightforward as it's often presented to be. The physics itself is completely settled, though, beyond any reasonable doubt. The relativity of simultaneity is absolutely real and has been confirmed countless times. The equations work flawlessly in every test we can devise. And what remains genuinely contested and debated is whether this physical reality forces us to accept the block universe interpretation as the correct metaphysical picture. Many physicists, when they think deeply and carefully about the implications of relativity theory, find themselves naturally drawn to the block universe view, because the mathematics seems to strongly suggest that space-time is a unified whole, with no objective present moment carved into it at any fundamental level. Einstein himself seemed sympathetic to this view throughout his later life. In March of 1955, shortly before his own death, Einstein wrote a letter to the family of his close friend Michel Besseau, who had recently died. In that deeply personal letter, Einstein offered comfort with an extremely striking statement about the nature of time and existence. He wrote that for those who believe in physics and take it seriously, the distinction between past, present, and future is only a stubbornly persistent illusion, nothing more. An illusion, that's the specific word Einstein chose to use. Not wrong exactly, but not capturing something objectively real about the fundamental structure of the world either. Think carefully about what it would genuinely mean for the distinction between past, present, and future to be an illusion in this sense. Right now, at this very moment, you're experiencing this moment, and it feels utterly real, utterly present, utterly now, in the most vivid possible way. The moments you remember from yesterday feel like the past, gone forever, no longer real or existent in any meaningful sense, while the moments you'll experience tomorrow feel like the future, not yet real, open and undetermined, waiting to be created. Einstein's profound suggestion is that this feeling, this deep sense of temporal flow and progression, is like an illusion, not in the sense that it isn't genuinely happening to you as an experience, but in the sense that it doesn't accurately reflect the objective structure of reality at its deepest level. Compare it to the illusion of the solid ground beneath your feet right now. The floor feels completely solid to your senses, but physics tells us clearly that it's actually mostly empty space, with atoms held apart by electromagnetic forces creating the appearance of solidity. And the solidity isn't exactly false as an experience, but it isn't what's fundamentally there at the atomic level either. The flow of time might work in exactly the same way as this analogy. Not exactly false as an experience, but not what's fundamentally there in the structure of reality either. If the block universe turns out to be accurate, then what's fundamentally there at the deepest level is a four-dimensional structure containing all events, past, present, and future, existing simultaneously. Your life is a thread woven through this structure from beginning to end. And your experience of now is something that happens at each point along the thread as you move through it. But the thread itself exists all at once within the block, laid out in its entirety. This is the part that still genuinely amazes me even after many years of thinking about this topic extensively. The idea that yesterday and tomorrow are both there in the structure, that they both exist in precisely the same sense that today exists, that the difference between them is somehow analogous to the difference between here and there in space, rather than the difference between real and not real in existence. Let me offer you another way to think about this concept that might help it click. Picture a novel that exists as a physical book with all the pages there at once, bound together. Chapter 1 exists. Chapter 10 exists. The ending exists. All equally real, as parts of the complete book sitting on the shelf. Within the story being told, the characters experience events in sequence, one after another. And for them, there's a flow from earlier events to later events, with the events of Chapter 1 feeling like they happen before the events of Chapter 10 in their experience. From outside the story though, from the perspective of someone actually holding the book in their hands, there's no flow whatsoever. All the chapters simply exist simultaneously, and the beginning and the ending are equally present, equally real, equally part of the book's existence as a complete object. If the block universe is correct about reality, then reality is something like a story that exists all at once in this way. We experience it in sequence, moving through it page by page, moment by moment, but the whole thing is there from beginning to end simultaneously. And past, present, and future are like earlier and later chapters, all equally part of the complete book of spacetime that exists as a whole. This analogy isn't perfect by any means, since in a novel, the story is told from outside by a reader, while in reality, we're characters within the story itself, with absolutely no access to any outside perspective beyond the universe. The analogy captures something genuinely valuable though, which is the profound difference between how something is experienced from within by participants and how it exists as a whole from an external viewpoint. Let me invite you to really think deeply about what this would actually mean for your own life and existence if it's true. If the block universe is correct about the nature of reality, then the you of yesterday still exists somewhere in space-time at the specific coordinates of yesterday. Not gone or disappeared, but just at a different location in the four-dimensional structure from where you are now. The you of tomorrow already exists at the coordinates of tomorrow in the structure. Not yet real or waiting to be created, but just at a location in space-time you haven't experienced from yet, but which already exists. Every single moment of your life is somewhere in space-time permanently. Birth, death, and absolutely everything in between. All of it there, existing, part of the permanent structure of the universe. For some people, this is deeply disturbing on a visceral level, seeming to imply that the future is completely fixed and determined, that free will is an illusion or impossible, that everything is predetermined and our choices don't matter. For others, there's something strangely comforting about it instead. Everything that has ever happened is still there in some meaningful sense, preserved forever. Everyone who has died still exists at the space-time coordinates of their life. And the past isn't lost or gone, but remains part of reality. For still others, both reactions seem like fundamental misunderstandings of what the block universe actually claims, since the block universe doesn't necessarily imply determinism in the sense people usually mean when they use that word, and doesn't make the past recoverable in any practical sense that would help us. We'll explore some of these implications in greater depth later, but for now, just sit with the idea for a while, since this is one of those profound concepts that rewards patient, sustained attention and contemplation. Now let's go deeper into the physics, because special relativity, as strange and counterintuitive as it is, was just the beginning of the story. The year 1915 brought Einstein completing his masterwork, general relativity, which he'd been working on for years. This theory extends special relativity to include gravity and gravitational effects, and makes the picture of space-time even more interesting and complex. In general relativity, space-time is not just a fixed four-dimensional stage on which events passively happen, but rather something dynamic and flexible that curves and bends in response to the presence of mass and energy within it. What we experience as the force of gravity is actually the curvature of space-time itself, not a force in the traditional sense at all. This has deep and profound implications for the block universe picture that we developed from special relativity. In special relativity, even though different observers disagree about simultaneity, you can still imagine slicing space-time into flat surfaces of now, one unique surface for each observer moving at different velocities. Different observers would slice it differently based on their motion, but the slicing itself remains conceptually possible in all cases. General relativity makes this much more complicated and challenging though. Many spacetimes that are valid solutions to Einstein's field equations don't admit any natural global slicing into space at a time that works across the entire universe. There's simply no way to extend a present moment across the entire universe in a well-defined, objective way that all observers could agree on. Some special spacetimes used in cosmology do allow convenient time coordinates that are useful for calculations. Our standard cosmological model uses a time coordinate that corresponds roughly to the age of the universe since the Big Bang, which is extremely useful for practical purposes. This is a model-dependent structure though, a choice we make for convenience rather than something carved into the fundamental physics at the deepest level. The mathematics of general relativity suggests strongly that space-time itself is the fundamental reality, and any division into space and time separately is something we impose on the structure rather than something inherent in the structure itself. This reinforces the block universe view even more strongly. If space-time is the fundamental thing that exists, and if slicing it into moments of now is arbitrary and observer-dependent rather than objective, then the four-dimensional whole seems to be what's genuinely real at the deepest level. And the three-dimensional present is just a particular way we look at it, a slice through it from our perspective. Let me help you visualize what this four-dimensional structure actually looks like as best we can with our three-dimensional intuitions. We're used to thinking in 3 dimensions: length, width, height. That's natural for us. We can easily picture a cube, or a sphere, or any 3-dimensional object in our minds. Adding a 4th dimension genuinely challenges our spatial intuition in fundamental ways because we can't directly visualize it. Here's a way to think about it though. That might help. Picture taking a movie of something simple, like a ball bouncing up and down repeatedly. Each individual frame shows the ball at a particular position at a particular moment. And now, picture stacking all those frames on top of each other with time running upward as the vertical axis. What you get is a kind of tube or trail showing all the positions the ball occupied throughout the entire movie from beginning to end. That tube represents the ball's world line through space-time. The complete 4-dimensional history of the ball from the beginning of the movie all the way to the end, all existing simultaneously in the structure. In the block universe, absolutely everything has a world line like this. Every particle, every object, every person that has ever existed or will ever exist. Your world line begins at your birth and ends at your death, stretching through space-time. And every moment in between is a point along that continuous world line, threading through 4-dimensional space-time. Now picture doing this for absolutely everything in the entire universe simultaneously. Every object's world line is there, tracing through space-time, curving toward each other when there's gravity warping space-time, intersecting when objects physically meet, branching when objects split apart into pieces. The result is a vast, intricate, unimaginably complex 4-dimensional structure containing everything that has ever happened and everything that ever will happen, past, present, and future, all woven together in the fabric of space-time as one unified whole. This is the block universe in its full glory. There's something I want to address directly because it's often the very first objection people raise when they hear about this. Doesn't this mean the future is determined and fixed? Doesn't this mean we have no free will whatsoever? This is an extremely deep question, and philosophers disagree vigorously about the answer. Let me offer a perspective that might help clarify things. The block universe doesn't necessarily tell us anything new about determinism or free will that we didn't already have reason to wonder about. And here's why that's the case. Suppose you make a decision tomorrow morning, choosing to have coffee instead of tea at breakfast. In the block universe view, that decision exists at a particular location in space-time with specific coordinates. The fact that it already exists in the 4-dimensional structure doesn't mean it was forced on you by external circumstances or that you didn't genuinely make the choice, but just means that your decision, whatever it turns out to be, is part of the structure. The block universe is just a description of what happens in space-time and doesn't tell us why things happen the way they do, or whether they had to happen that particular way instead of differently. Those are separate questions entirely. Compare it to a map of a city. A map of your city shows all the roads and buildings in their locations. And if you drive from your house to the grocery store, the route you take exists on the map, represented there. But the map didn't make you take that particular route. The map just shows what's there in the territory. The block universe shows what happens in space-time in exactly the same way. It doesn't tell us whether what happens was inevitable or whether it could have been different under other circumstances. And those questions require additional philosophical work beyond just physics. Some physicists and philosophers do think the block universe supports determinism strongly, arguing that if the future already exists as part of the structure, it seems like it must be fixed and unchangeable. Others point out that this conflates 2 completely different questions that should be kept separate. Does the future exist? And is the future determined by the past and laws of physics? These might be entirely separate issues that don't necessarily go together. I don't want to pretend this debate is resolved or settled because it absolutely isn't among philosophers. But I also don't want you to think that accepting the block universe automatically means accepting that your choices don't matter or that you're just a puppet. That's a further claim requiring separate argument and justification. Let me share some specific numbers that might help you feel the scale of what we're actually talking about here and make it more concrete. Light travels at exactly 297,790,458 meters per second, approximately 670,616,629 miles per hour, or about 1,079,250,149 kilometers per hour in metric units. In 1 year, light travels approximately 9.46 trillion kilometers, or about 5.88 trillion miles through space. And that distance is what we call a light year, our standard unit for cosmic distances. Approximately 2.5 million light years separates us from the Andromeda galaxy. And let me help you feel what that distance actually means in more intuitive terms. Converting the distance to Andromeda into meters gives approximately 2.365 times 10 to the 22nd power meters, which is a 2 followed by 22 zeros. In miles, it's approximately 1.47 times 10 to the 19th power miles, which is a 1 followed by 19 zeros. These numbers are almost impossible to grasp intuitively, but here's what they mean for the Andromeda paradox we discussed earlier in concrete terms. When two people walk past each other at about 1 meter per second in opposite directions, the difference in their simultaneity assignments for events in Andromeda is about 3.05 complete days. Walking at a brisk pace of about 1.4 meters per second grows the difference to about 4.26 days just by walking a bit faster. Not by traveling in a rocket ship, not by approaching anywhere near the speed of light, just by walking at everyday normal human speeds that we use all the time. The reason the effect is so dramatically large despite the slow speeds is because of that vast cosmic distance involved. The formula for the simultaneity shift depends on both the relative velocity between observers and the distance to the events in question, multiplied together. And across a room, the effect is immeasurably tiny, far below what we could ever detect. Across Earth's diameter, about 12,742 kilometers, with a relative speed of 1 meter per second between observers, the shift is only about 0.142 nanoseconds, which is why we never notice this phenomenon whatsoever in daily life around us. Across 2.5 million light years, though, even tiny relative velocities translate into multiple days of disagreement about now, which is staggering. Think carefully about what that means for any hope of an objective present moment existing in reality. If you and I can disagree about what's happening now in Andromeda by multiple days based on nothing more than our walking speeds relative to each other, then now in Andromeda is not an objective feature of reality at all. It depends on motion, and it's relative to the observer. If now in Andromeda isn't objective, what about now in the next room from where you're sitting? In principle, the exact same effect applies there too, just far too small to measure with any conceivable instrument. The lesson is the same though, regardless of scale. Simultaneity is not built into the fabric of spacetime as an objective feature, but is something that observers construct from their reference frames, and different observers moving differently construct it differently. This is one of the deepest lessons of special relativity, and it took many decades for its full implications to be appreciated by the scientific community. Let me shift our attention to something closer to home and more immediate. Your direct experience of time as you're living through it right now. Whatever the physics says about space-time at the deepest level, you experience time as flowing forward, with the present moment feeling intensely real and vivid, the past feeling gone and accessible only through fallible memory, the future feeling open and undetermined and not yet there, waiting to be created. This experience is universal among humans across all cultures and time periods, and we all feel time passing moment by moment. All experience the now as special and unique. All feel like the future is something we're moving towards step by step. Where does this powerful experience actually come from, though? Philosophers call our experience of the present moment the specious present, which is a technical term, the brief window of time that feels like now to us in our subjective experience. Psychological research suggests this window runs about 2 to 3 seconds long typically, and within this window, events feel simultaneous and present, while outside it, events feel like the past or anticipated future. Why do we have this experience though? And why does it feel so strongly like time flows forward? Modern neuroscience suggests that our experience of time is constructed by our brains through complex neural processing. We don't perceive time directly the way we perceive light or sound through sensory organs, but instead piece together a sense of time from memory, prediction, and neural dynamics in the brain. Research has identified specialized time cells in the hippocampus and entorhinal cortex that seem to track the passage of time internally. These neurons fire in specific sequence, creating a kind of internal clock that helps us situate events in time and distinguish past from future events. Here's the key point though. That's crucial to understand. All of this happens inside our brains as neural processing. Our experience of temporal flow is something our nervous system constructs actively, a feature of how conscious experience works in brains, rather than necessarily a feature of external reality itself. In the block universe picture, this actually makes perfect sense and fits naturally. If all of space-time exists together as a unified structure, then what we call the flow of time is something that happens within conscious minds situated at particular points along their world lines through space-time. Each conscious moment has the experience of being now, with memories of the past and expectations about the future built into that moment. But objectively, from outside the world line, if such a perspective were possible, there is no flow at all. The world line just is, existing all at once. This is a genuinely strange idea to contemplate. It suggests that one of the most basic features of our experience, the feeling that time passes moment by moment, might not correspond to anything in the physical world at all. The passage of time might be like the apparent motion of the sun across the sky each day, real as an experience we have, but not reflecting what's actually happening in physical reality. If time doesn't really pass in any objective sense, why do we experience it as passing so strongly? This is a deep and difficult question without an easy answer. One answer that's compatible with the block universe is that each moment of consciousness along your world line includes experiences that feel like flow and progression. Each moment includes memories of the immediately preceding moments, creating a sense of continuity linking them. And each moment includes anticipation of what comes next, creating a sense of moving forward into the future. You don't need time to actually flow in any objective sense for this to work experientially. You just need each moment to contain the appropriate mental states, the memories, the anticipations, the sense of, this is now. And if those mental states are present at each point along your world line, then you'll experience flow at each point individually, even if the world line as a whole is actually static and unchanging. It's like how each frame of a movie contains the appearance of motion when shown in sequence. Even though the frames themselves are static images on film, the motion isn't in any single frame, but emerges from the relationship between frames shown rapidly. The sense of temporal flow might work in exactly the same way, not existing in any single moment, but emerging from the relationships between conscious states along the world line as you move through them. This is speculative, of course, and we don't fully understand consciousness yet, or how it relates to the structure of spacetime at a fundamental level. The block universe provides a framework for thinking about these questions though, one that many philosophers and physicists find illuminating and worth exploring further. There's another aspect of time we absolutely need to address before moving on: the arrow of time, which is the direction from past to future. Even if the block universe is correct, and all of space-time exists together as a unified block, there's still something undeniably special about the direction we call future as opposed to past. We remember the past, but not the future. We can affect the future, but not the past, and cause comes before effect rather than after. Where does this asymmetry come from if the block is symmetric? The fundamental laws of physics as we understand them today are largely time-symmetric at the deepest level. Run them forward or backward in time, and they work equally well mathematically. If you film a simple physical process like balls colliding, and then play the film in reverse, the reversed version is just as physically valid as the original version according to the laws. Why does time seem to have a direction then in our experience? The answer that physicists usually give involves thermodynamics and a concept called entropy, which is crucial. Entropy is, roughly speaking, a measure of disorder or randomness in a system. A neat, ordered state has low entropy, while a messy, disordered state has high entropy. The second law of thermodynamics says that in an isolated system, entropy tends to increase over time on average. This gives time a direction in our experience. The future is the direction in which entropy increases, and the past is the direction in which entropy was lower. Here's the deep puzzle that arises though. Why was entropy low in the past to begin with? The fundamental laws of physics don't explain this at all, since they're time-symmetric and don't prefer low entropy in the past any more than in the future. The standard answer physicists give is what they call the past hypothesis. which is essentially an assumption. The assumption that the early universe, near the Big Bang, was in an extraordinarily low entropy state for reasons we don't fully understand. From that starting point, entropy has been increasing ever since according to the second law, giving us our arrow of time that we experience. Recent work from 2024 and beyond has connected this to quantum mechanics and a concept called decoherence, which is fascinating, the process by which quantum superpositions become classical-looking states. Some researchers have argued that the arrow of time emerges from the interplay between the past hypothesis and the dynamics of entanglement and decoherence at the quantum level, which is still being researched. What does this mean for the block universe specifically? It means that even within the block, there's a direction built into the pattern, an asymmetry. Not because the block is incomplete on one end or the other, but because the pattern of events within the block is asymmetric in a specific way. One direction has lower entropy than the other direction. Memories and records point in that direction of increasing entropy, and causation works in that direction as well. The block universe doesn't deny that time has an arrow, or direction, in this sense. It just says that the arrow is a feature of the pattern of events within the block, rather than evidence that the future doesn't exist yet, or that time literally flows forward. Think of it like a painting of a landscape hanging on a wall. The painting might show a river flowing from mountains to the sea, and within the painting, there's a clear direction of flow, with water going from higher to lower elevation. The painting itself is static though, not moving or changing, and the flow is a pattern in a static image rather than actual motion. The arrow of time in the block universe works in exactly the same way, a pattern in a static four-dimensional structure that exists all at once. The pattern is absolutely real, the asymmetry is absolutely real and measurable, but it doesn't require time to actually flow in any objective sense to exist. Let me walk through the history of how these ideas developed over time, because I think the evolution of understanding is as fascinating as the ideas themselves and shows how science progresses. Before Einstein arrived on the scene, time was simple and straightforward. Newton's physics treated time as absolute and universal, with everyone everywhere agreeing on what now meant, regardless of their state of motion. Time was a dimension, certainly, but it was special and privileged, different from the three dimensions of space in fundamental ways. Philosophers debated whether the past and future existed as real things, but this was pure metaphysics rather than physics, since the physical laws didn't have anything to say about it one way or the other. The year 1905 brought special relativity bursting onto the scene, with Einstein showing conclusively that time is not absolute after all. Different observers in relative motion disagree about simultaneity, and the now is not universal across space. This was revolutionary at the time, but the full implications took considerable time to sink in among physicists and philosophers. The year 1908 brought Minkowski providing the mathematical framework of four-dimensional spacetime, making clear that space and time are unified into one structure, and that events are points in a four-dimensional structure rather than three-dimensional space changing over time. Minkowski didn't fully explore the philosophical implications for the nature of time though, focusing more on the mathematics. The year 1915 brought general relativity, extending the picture to include gravity and curved spacetime in a beautiful geometric theory. The mathematics became more complex and sophisticated, but the basic lesson was reinforced even more strongly. Spacetime is the fundamental reality, not space and time separately. It wasn't until the 1960s that philosophers began to seriously work out in detail what relativity implies about the existence of past and future. The year 1966 brought C.W. Rietvik publishing a paper titled A Rigorous Proof of Determinism Derived from the Special Theory of Relativity in the journal Philosophy of Science. Rietvik argued that special relativity implies that events we call future are just as real as events we call past, because for some other observer moving differently, they're already in the past and therefore must exist. The year 1967 brought Hilary Putnam publishing Time and Physical Geometry in the Journal of Philosophy, developing a similar argument independently. Putnam argued that special relativity creates strong pressure against presentism, the view that only the present exists because of the relativity of simultaneity. These papers sparked decades of intense philosophical debate that continues to this day. Some philosophers accepted the arguments and embraced the block universe wholeheartedly, while others found ways to resist arguing that relativity doesn't force the metaphysical conclusions that Rettig and Putnam drew from it. The debate continues to this day with no clear resolution. The year 2021 brought Jarenscheffer publishing a paper in the research notes of the American Astronomical Society, offering a critical analysis of the Andromeda paradox, arguing that the usual metaphysical takeaway is not as straightforward as often presented in popularizations. The physics of special relativity is not in dispute at all. The equations work flawlessly, and relativity of simultaneity is real and confirmed. Whether this forces us to accept the block universe interpretation remains a matter of ongoing philosophical debate though, with smart people on both sides. What I can tell you is that many physicists, when they think carefully and deeply about relativity, find themselves drawn towards some version of the block universe view as the most natural interpretation. The mathematics seems to suggest strongly that spacetime is a unified whole, and the distinction between past, present, and future is not carved into the equations at any fundamental level. Physics alone may not be able to settle the metaphysical question definitively though. What exists is a philosophical question, and the answer may depend on arguments that go beyond what the physics equations can tell us directly. Now let's explore some of the implications of the block universe if it turns out to be correct about reality. One implication is about identity and persistence through time. In our everyday thinking, we assume that the you of yesterday and the you of today are the same person in some deep sense, that you persist through time as one continuous entity. What does this mean in a block universe though, where there's no time flow? In the block universe, there isn't really a you that moves through time like a traveler on a road. Instead, there's a world line, a four-dimensional thread through space-time containing all the momentary stages of your existence from birth to death. Each stage is connected to the next by physical and psychological continuity, but no stage is literally moving to the next stage. What makes these different stages the same person is not that they share some continuing substance that moves through time like a soul or essence. It's that they're appropriately connected to each other through causation, memory, and physical continuity in specific ways. This might sound abstract, but it has concrete implications for how we might think about personal survival and death in this framework. In the presentist picture, when you die, you cease to exist entirely. The you that was there is no longer there anywhere, and the present moment marches on without you into a future you're not part of. In the block universe picture, death works differently in an interesting way. The world line has an endpoint, a last moment at specific space-time coordinates. But that moment doesn't disappear or cease to exist. It's there at its coordinates in space-time permanently, and the you at your death exists in precisely the same sense that the you at your birth exists. Both are part of the block structure. Does this mean you're immortal in some sense? No, not in any practical sense whatsoever. Your world line is finite with only so many moments along it, and after the last moment, there are no more moments at all. It might mean that existence is more permanent than we usually think though. The moments of your life are not lost when they pass, but remain in the four-dimensional structure forever as permanent features. Einstein seemed to find some comfort in this view toward the end of his life. Remember his letter to the Besso family, where he said the distinction between past, present, and future is a persistent illusion? He wrote that letter to comfort them after Besso's death, suggesting that in some meaningful sense, Besso's existence was not ended or destroyed, but remained part of the structure of space-time eternally. Whether you find this comforting or disturbing probably depends on your temperament and values. Some people find the permanence reassuring, with every moment lived and every experience had preserved in the block forever. Others find the lack of genuine flow distressing, wondering what's the point if everything already exists, and what there is to strive for if the future is already there. These are genuinely deep questions, and I don't think physics can answer them for us. The block universe, if true, tells us something about the structure of reality, but what it means for our lives and how we should live is something we each have to work out for ourselves philosophically. Let me bring this back to human scale for a moment, because I think it's easy to lose sight of how extraordinary all of this is. You woke up this morning, probably had breakfast or coffee, and are listening to or watching this right now at this very moment. These all seem like ordinary experiences happening in ordinary time, one after another in sequence. According to what we've discussed though, Each of those moments is a point in a four-dimensional structure, each existing as specific coordinates in spacetime, and each as real as any other point. The you who woke up this morning is there at those coordinates having that experience permanently. The you experiencing this moment right now is here at these coordinates having this experience permanently. Neither is more real than the other in any objective sense. And both exist in the structure, the sense that this moment is special, that it's now, that it's the one real moment while others are gone or not yet here. That sense is happening at every point along your world line as you experience each point. Every moment feels like now from within when you're at that point experiencing it. When I first really grasped this deeply, I had to sit with it for a long time and let it sink in. It changes how you relate to time in subtle ways. Not necessarily in a practical way, since you still plan for the future and remember the past and live your life normally, but in an existential way, in how you think about what it means to be. The texture of experience feels different when you think about it this way, more spacious somehow. Let me explore something that might seem like an objection to the block universe that often comes up: quantum mechanics and its implications. Quantum mechanics is the physics of the very small, of atoms and particles and photons at the tiniest scales. And it's famous for involving randomness and uncertainty in fundamental ways. Particles don't have definite properties until they're measured according to standard interpretations. And outcomes are probabilistic rather than deterministic. Some people think quantum mechanics might rescue presentism and the open future from the block universe. If the future is genuinely random and genuinely not determined by the present, then it might not exist yet, they argue. Quantum mechanics might show that the block universe is incomplete or wrong about the future. This is a complex topic, and physicists disagree about it vigorously. Let me share what I think is a fair summary of the current state of things. Quantum mechanics does introduce something that looks like fundamental randomness at the deepest level. When you measure a quantum system, you get one of several possible outcomes with probabilities determined by the system's state before measurement, and no one can predict with certainty which outcome will actually occur in any given case. Here's the thing though, this doesn't obviously contradict the block universe at all. The block universe just says that whatever happens is part of the four-dimensional structure, and it doesn't say that what happens is predictable or determined in advance by prior states. In the block universe, the quantum measurement and its outcome both exist at their space-time coordinates as real events. The outcome exists in the structure, but that doesn't mean it was predictable before it happened to anyone. Think of it this way to see the point. Picture flipping a coin with the outcome, heads or tails, being genuinely random and unpredictable. You can't predict it before the flip, but once it happens, it has happened and is part of history permanently. In the block universe, the future works the same way. Quantum randomness might mean we can't predict what's in the future, but that doesn't mean the future doesn't exist. It just means we don't know what it is until we get there and experience it. This is subtle, and not everyone agrees with this interpretation by any means. Some interpretations of quantum mechanics, like the many worlds interpretation, are very compatible with the block universe naturally. In many worlds, all possible quantum outcomes are real, each in its own branch of the wave function splitting off. And this is an extreme block universe, where even more exists than in the standard picture we've been discussing. Other interpretations, like some versions of the Copenhagen interpretation, are less clearly compatible with the block universe. They emphasize that quantum outcomes become definite only upon measurement, which might suggest that future measurements don't have definite outcomes yet, and therefore don't exist. This is an active area of research and debate in the foundations of quantum mechanics, and the relationship between quantum mechanics and the block universe is not fully worked out yet. I don't think quantum mechanics clearly refutes the block universe though, because the picture is more complicated than simple arguments suggest. Let me talk about something that might seem mundane, but is actually deeply connected to these ideas in surprising ways. Why do we remember the past and not the future at all? This is a strange question when you first hear it. Of course we remember the past. That's what memory is by definition. In the block universe though, past and future are both there equally in the structure. So why should we have access to one direction and not the other? Why is memory asymmetric? The answer connects to entropy and the arrow of time that we discussed earlier. Memories are physical records, patterns in your brain, states of neurons that correlate with past events that caused them. These patterns are formed by the causal influence of past events on your brain through various physical processes. For such records to form reliably, you need a direction of increasing entropy overall. Records and memories are examples of low entropy correlations, ordered patterns that carry information about other events. And for such patterns to form consistently, you need to start from a low entropy state in one direction. This is why memories point toward the past rather than the future. The past is the direction of lower entropy, the direction from which the ordered state came initially. And records form in the direction of entropy increase naturally. If entropy decreased toward the future instead of increasing, we would have records of the future instead of the past. Our memories would be of events that, from our current perspective, haven't happened yet. This sounds bizarre and impossible, but physics doesn't actually forbid it in principle. It's just that in our universe, the boundary conditions establish low entropy in the past, rather than the future for reasons connected to the Big Bang. This is why memory doesn't refute the block universe at all. Memory is not a perception of what exists versus what doesn't exist ontologically, but rather a physical process that creates correlations in one temporal direction rather than the other direction. And that direction is set by the thermodynamic arrow of time. In the block universe, both past and future exist equally in the structure. But our brains as physical systems embedded in the block form correlations primarily with the low entropy direction, which we call the past. This is one of those ideas that takes considerable time to absorb fully. Our experience of time is so immediate, so fundamental to consciousness, that it feels like it must be reflecting something basic about reality itself. The idea that memory is just a thermodynamic phenomenon, that our sense of the past is a consequence of entropy conditions rather than a window onto what truly exists versus what doesn't, is deeply counterintuitive. Counterintuitive doesn't mean wrong, though, as science has shown us many times. Many of the deepest insights in physics have been counterintuitive when first proposed. The Earth moving around the Sun was counterintuitive to everyone who first heard it. Quantum mechanics is counterintuitive in countless ways. Sometimes reality is just different from what our everyday experience suggests to us. Let me talk about cosmology for a moment, because it adds another layer to this discussion that's important. Our current cosmological model describes a universe that began in a hot, dense state about 13.8 billion years ago, and has been expanding and cooling ever since that initial moment. This is often called the Big Bang, though that's somewhat misleading as a term. In this model, time has a beginning in a sense. There was a first moment, or at least something approaching a first moment. And before that point, our current physics breaks down completely, and we don't know how to describe what was there, if anything. What does this mean for the block universe? If the universe has a temporal beginning, then the block is not infinite in the past direction. There's an edge to spacetime, a boundary where things start. This might seem to conflict with the block universe picture somehow, but it doesn't really conflict at all. The block universe just says that spacetime is a four-dimensional structure, and that all the events within it are equally real regardless of when they occur. It doesn't say the structure has to be infinite in all directions necessarily. The block can have edges and boundaries perfectly well. The standard cosmological model is naturally described in block universe terms, in fact. Cosmologists routinely describe spacetime as a whole from the Big Bang to the far future, drawing diagrams showing the entire history of the universe, past, present, and future, as a single four-dimensional structure laid out. Cosmology reinforces the block universe picture strongly. If anything, the mathematics of general relativity, which underlies all of cosmology, naturally describes spacetime as a unified entity existing all at once. Cosmologists don't usually think of time as flowing when they work, but rather think of spacetime as existing as a complete structure. Cosmology also raises interesting questions, though, that are worth considering. What about the far future of the universe? Does it exist yet? Or will it come into existence later? In the block universe view, yes, it exists. If the block includes all of spacetime, then it includes not just the Big Bang, and now and next year, but also events billions of years in the future. The eventual fate of the universe, whatever it turns out to be, is already part of the block structure. This might seem strange when you first think about it. How can events that won't happen for billions of years already exist right now? Remember though, the block universe says that already and not yet are perspectival notions tied to a particular observer's world line from within the block at any given point they're experiencing. Some events are in the past relative to that point, and some are in the future relative to it. The block as a whole just is, though, and doesn't have a now that divides it objectively. The far future exists in precisely the same sense that the far past exists in the structure. We just happen to be located at our particular position in the block, unable to directly perceive the distant parts in either direction. Let me address another common concern that people have about this. If the future already exists in the block, can we change it through our actions? This might seem like an obvious no at first glance. If the future is already there, fixed in the block, then we can't change it, right? This reasoning might be confused though, and let me explain why carefully. In the block universe, the future is determined in the sense that it has a definite content. There are facts about what happens tomorrow, just as there are facts about what happened yesterday. This doesn't mean your choices don't matter though, which is crucial to understand. Your choices are part of the block structure. When you make a decision, that decision is an event in spacetime located at particular coordinates, and the decision causally influences later events in the normal way. Your actions shape the future through causal connections. The block universe doesn't say your choices are overridden by some external fate or destiny. It says your choices are part of the structure and are included in what happens and makes the structure be what it is. Think of it this way to clarify the point. Suppose you're deciding whether to have coffee or tea tomorrow morning. Whatever you decide, that decision will be part of the block at those coordinates. If you decide coffee, then the block contains you deciding coffee at those coordinates. If you decide tea, then the block contains you deciding tea at those coordinates. The block doesn't decide for you somehow. You decide, and your decision is what makes the block be the way it is, rather than some other way. This might seem like a subtle point, but it's extremely important to get right. The block universe is not fatalism at all. Fatalism says your choices don't matter, that things will happen regardless of what you do. The block universe says your choices matter enormously, since they're what determines the shape of the block through causal connections. The difference between the block universe and everyday thinking is not about whether choices matter, but about the relationship between what you choose and what exists. In everyday thinking, your choices determine a future that doesn't exist yet and comes into being. In the block universe, your choices are part of a structure that exists timelessly. In both pictures, though, choices are causally effective in shaping outcomes. Let me be fair and present some of the alternatives to the block universe that philosophers have proposed. Not everyone who understands relativity accepts eternalism, and there are other views that try to preserve more of our intuitive picture of time while accommodating the physics somehow. One alternative is called the growing block theory, which is interesting. In this view, the past and present exist, but the future does not exist yet. The block is not complete but growing as time passes, and each moment new events come into existence and are added to the block permanently. This preserves the sense that the future is open, that it genuinely doesn't exist yet, while still accepting that the past exists and that past events are not simply gone. The growing block theory faces a serious challenge from relativity of simultaneity, though. If there's no objective now that divides what exists from what doesn't, then where does the edge of the growing block lie? Different observers would disagree about where the boundary is between existence and non-existence, which seems to imply that the boundary isn't objectively real at all. Defenders of the growing block have proposed various responses to this challenge over the years. Some suggest that there's a privileged foliation of spacetime, a particular slicing into moments that represents the true boundary of existence, even if observers can't detect which one it is. Others have developed more sophisticated positions that try to accommodate relativistic effects in different ways. Another alternative is called presentism, which we've mentioned already. The view that only the present exists, period. Past events have ceased to exist entirely, and future events don't exist yet at all, with only the instantaneous present being real at any given moment. Presentism matches our intuitive experience very well indeed. The present feels special and unique, the past feels gone and finished, and the future feels open and not yet here. Presentism has a harder time with relativity than the growing block does, though, facing serious challenges. If the present is all that exists, and if relativity shows that the present is observer-dependent, then what exists would be observer-dependent in a troubling way. Different observers in relative motion would have different presence, which would mean they'd have different realities existing for them. This seems deeply problematic philosophically. Presentists have proposed various responses to try to save the view. Some accept that there's a privileged frame of reference that defines the true present, even if relativity doesn't reveal which frame it is or give us access to it. Others have tried to reformulate presentism in ways that avoid the problem through technical philosophical moves. I want to be clear that these are live philosophical debates with smart people on all sides. The block universe is not the only option available, and smart people disagree about these questions vigorously. The physics alone may not settle the metaphysics definitively. What I can say is that the block universe is taken seriously by many physicists precisely because it seems to fit most naturally with the mathematics of relativity. When you write down the equations of special and general relativity, they describe a four-dimensional spacetime rather than a three-dimensional space evolving in time. The natural interpretation of the mathematics is that spacetime is the fundamental reality existing all at once. Interpretation is where philosophy enters though, and physics equations can be interpreted in more than one way potentially. The debate continues among philosophers and physicists. Let me talk about something that often comes up in these discussions. What would it actually mean for the block universe to be true about reality? I've already touched on some implications, but let me go deeper into what it means. If the block universe is true, then your entire life already exists in the structure. From your birth to your death, every moment is there in space-time permanently. The choices you'll make, the experiences you'll have, the successes and failures and joys and sorrows, all of it part of the structure existing eternally. This might make you feel like a character in a story that's already been written, and in a sense, that's true. You're a character who experiences the story from within though, making choices that feel genuinely open and living through each moment as if it were newly happening for the first time. The interesting question is which perspective is more fundamental here? Is the outside view, where the whole block exists at once, the real picture, with the inside view being an illusion or mere appearance? Or are both perspectives equally valid, just different ways of relating to the same reality from different standpoints? I'm inclined to think both perspectives are real and valid in their own ways. The block exists as a whole, and that's a genuine fact about reality at the deepest level. But you also genuinely experience time from within sequentially, moment by moment. And that's not a mistake or a misperception of what's really there. It's just what it's like to be a conscious being embedded in a particular location within the block, experiencing from that perspective. Compare it to spatial perspective, which works analogously. From where you're sitting right now, some things are in front of you, and some are behind you. And that's real. It's your actual perspective from your location. There's also a view from nowhere though, a description of where everything is without privileging any particular location, and that's also real and valid. There might be both your temporal perspective, where some events are past and some future, and a view from no-when, where the whole of space-time is laid out without privileging any moment. Both are real, just different ways of describing the same reality from different standpoints. Let me share some thoughts about how I've come to think about my own life in light of these ideas over time. When I think about past experiences, good and bad, I sometimes remind myself that in the block universe picture, those moments are still there in the structure. The joy of a wonderful day years ago isn't lost or gone into non-existence, but exists at its space-time coordinates as real as today is. When I think about the future and what's coming, I sometimes remind myself that from a certain perspective, it's already there in the structure. The uncertainty I feel about what will happen is a feature of my perspective and limited knowledge rather than a feature of the structure of reality itself. When I think about mortality, about the fact that my world line has an endpoint somewhere in space-time eventually, I try to remember that ending a world line is not the same as erasing it from existence. The moments of life remain part of the block even after the world line ends, preserved forever. I'm not sure these reflections change anything practically in how I live, since I still plan for the future, still cherish memories, still feel the passage of time moment by moment in my experience. There's something about the block universe perspective that I find clarifying though. A reminder that our usual way of thinking about time, the though natural and useful, is not the only way to think about it. The texture of reality might be richer than our everyday perspective suggests. Let me take you through some thought experiments that might help make these ideas more vivid and concrete. Picture stepping outside of space-time somehow and looking at it from the outside, like looking at an object. What would you see from that impossible vantage point? You'd see a vast four-dimensional structure containing all the events of history laid out before you. Galaxies forming and dissolving over billions of years. Stars burning and exploding in supernovae. Planets coalescing from dust and gas. Life arising and evolving in countless forms. Civilizations building and falling across the cosmos. Everywhere threading through this structure would be the world lines of individual objects and beings. Your own world line would be there among them, a thin thread connecting your birth coordinates to your death coordinates. You'd see your entire life laid out at once. Every moment you've experienced and will experience from the perspective of someone who can see the whole thing at once laid out. From this outside perspective, there's no flow whatsoever. The structure just is, existing as a complete whole. And every event is equally present, equally real, equally part of the structure. The distinctions we make between past, present, and future are not visible from out here, since they're features of perspective rather than features of the structure itself. You can't actually step outside of space-time, of course. You're embedded in it, and your perspective is necessarily from within as a participant. The thought experiment might help you grasp what the block universe claims, though, that the external view, even if inaccessible to us, is a valid description of reality. Here's another thought experiment to consider. Picture meeting someone from the far future in the block universe framework. This person already exists at their coordinates in space-time living their life, just as you're at yours living yours. The fact that you can't currently interact with them doesn't mean they're not there, since they're just in a different part of the block from you. This is strange to think about carefully. Someone who won't be born for centuries from your perspective is nevertheless there in the structure as real as you are right now at this moment. Their experiences are happening at their location in space-time. They have a perspective on time just as you do from their location. And they remember what for you is the far future as their past already happened. If you could somehow meet this person, you might find their existence hard to process psychologically. They're from the future from your perspective, but from their perspective, they're just from now like you are. Their now and your now are both parts of the same structure, just at different coordinates. Let me give you some more numbers that might help ground these abstractions in concrete terms. The visible universe spans about 93 billion light years in diameter currently. That's the part we can in principle observe, given the age of the universe and the speed of light as a limit. And in meters, it's approximately 8.8 times 10 to the 26th power meters, which is an incomprehensibly large number. The age of the universe sits at about 13.8 billion years, or about 4.35 times 10 to the 17th power seconds. These numbers describe the current extent of the observable universe in space and time that we have access to. But in the block universe picture, the structure extends far beyond what we can currently observe from our position. The future of the universe, whatever it is part of the block. The parts of the universe beyond our current horizon, outside our observable range, are part of the block. The block contains everything that exists. Every galaxy we can see, and every galaxy we can't see. Every moment from the Big Bang to the far future. All of it there in the four-dimensional structure existing simultaneously. Let me return to the Andromeda paradox one more time, because I think it's such a striking illustration of what's at stake here. The Andromeda galaxy sits 2.5 million light years away from us. Two people walk past each other on Earth with their relative speed at maybe 1 to 2 meters per second. Nothing dramatic. Their disagreement about what's happening now in Andromeda amounts to multiple complete days. Think about what kinds of events might be at stake in those days. An Andromedan war council deciding whether to invade another star system. An Andromedan scientist making a breakthrough discovery. An Andromedan couple getting married. An Andromedan artist creating a masterpiece. For one observer on Earth, these events are in the past, settled, already happened and done. For another observer walking in the opposite direction, these events are in the future, not yet occurred from their frame. Which observer is right about what exists? According to special relativity, both are, or rather the question doesn't have an objective answer at all. Now in Andromeda is not a fact of the matter, but is observer-dependent based on motion. If you're a presentist believing only the present exists, you have a serious problem here. What exists depends on how fast you're walking, which seems absurd. If you accept the block universe, the problem dissolves naturally. All the events in Andromeda exist at their coordinates in spacetime. And the question of which ones are now is just about which ones are simultaneous with you from your frame, which is observer-dependent. It doesn't affect what exists in the structure, though. This is why the Andromeda paradox is such a powerful illustration of these concepts. It takes the abstract physics of relativity of simultaneity and shows with concrete numbers just how dramatic the disagreement can be between observers. Days of difference from walking speed alone. Let me talk about something that might seem like a tangent, but is actually deeply connected to everything we've discussed: the nature of change itself. In our everyday experience, things change constantly. The sun rises and sets each day. People grow older year by year. Buildings are constructed and demolished. Change seems fundamental to reality itself. What is change in the block universe framework, though? In the block universe, change is a pattern within the structure rather than a feature of the structure itself. At one set of coordinates, the sun is in one position in space, and at later coordinates along the time axis, it's in a different position. This difference between the earlier and later states is what we call change when we experience it. The structure itself doesn't change, though, which is key to understand. It's a static four-dimensional object, and change is within the block rather than of the block itself. This might seem to contradict our experience directly. We experience change as happening, as events unfolding, and experience the world as dynamic rather than static. Remember though, our experience is from within the block at particular locations. We are conscious beings at particular locations in space-time, moving along our world lines. And at each location, we have certain experiences, including experiences of things changing around us. The experience of change is absolutely real as an experience. But the experience is a pattern in a static structure, rather than evidence that the structure itself is changing or evolving. This is subtle and worth spending considerable time with. The block universe doesn't deny that change happens in any meaningful sense, but reinterprets what change is fundamentally. Change is difference across time, a pattern within the block. What the block universe denies is that the block itself evolves or grows or comes into being. Think about a painting of a river to understand this better. In the painting, the river appears to flow, with brush strokes suggesting motion, ripples, currents flowing downstream. An observer looking at the painting sees a river in motion, flowing. The painting itself is static though, an object, a canvas with pigments on it that doesn't change at all. The flow of the river is a pattern in the static painting, rather than a change in the painting itself. The flow of time in the block universe works in exactly the same way by analogy, a pattern in the static four-dimensional structure rather than a change in the structure itself. The pattern is absolutely real, and we experience it. But what's real is a static block containing the pattern, rather than a changing reality whose state is given by the present moment alone. Here's a question that often comes up in discussions. If the block universe is true, does anything happen at all? This might seem like a strange question on the surface. Of course things happen. You woke up this morning, the sun rose, people were born and died around the world. These are things happening. Happening might be a loaded word though, carrying philosophical baggage. It suggests process, becoming, unfolding, the world moving from one state to another through time. In the block universe, none of this is quite right as a description. Events don't happen in the sense of coming into existence from non-existence. They don't become real through some process, but just are at their locations in space-time permanently. Events are real though, absolutely real. The birth of a child is a real event with real coordinates in space-time. The death of a star is a real event. Your reading or listening to this sentence right now is a real event. These events exist in the four-dimensional structure as genuine parts of it. The right thing to say might be that events exist, but they don't happen if happen implies coming into being from nothing. They just are, existing timelessly. This is a philosophical subtlety, and you might think it's just playing with words unnecessarily. I think it captures something valuable about what the block universe claims, though. The claim is not that nothing is real or that events don't exist, but that what's real is a static structure containing all events rather than a dynamic process of becoming. Let me talk about how these ideas relate to age-old human questions about mortality and meaning that have preoccupied us forever. Humans have always wondered what happens after death with deep existential concern, and every culture throughout history has stories about what lies beyond, about afterlives and rebirths and final ends and judgments. The block universe offers its own unique perspective on death that differs from traditional views. In this view, death is the end of a world line at specific coordinates, the last moment in a finite thread through space-time. The thread doesn't vanish or cease to exist, though, which is important to understand. The moments before death remain at their coordinates in the structure forever. This might be cold comfort in many ways. You can't return to those moments or relive them from your present perspective. They're there, but you're not accessing them, and your consciousness, whatever it is, doesn't persist beyond the end of the world line in any obvious way. Or does it? This is where things get philosophically murky and uncertain. What is consciousness exactly? How does it relate to the moments along a world line? If each moment is there in the structure, is the consciousness associated with each moment also there somehow? These questions go far beyond what physics can answer for us. They touch on the hard problem of consciousness, on the nature of subjective experience, on what it is to be a self persisting through time. Deep mysteries remain. Some people find the block universe picture comforting, despite these uncertainties and unknowns. Even if consciousness doesn't persist, the moments of life do persist. Your happiest days are there in space-time forever, preserved. Your worst days are there too, but they don't erase the good ones. Everything is preserved eternally. Others find no comfort in this at all. What good is preservation if you can't experience it from your current moment? What good is the eternal existence of past moments if the you that lived them is gone from now? I don't have answers to these questions, since they're among the deepest questions humans can ask about existence. What I can say is that the block universe provides a framework for thinking about them systematically, a context in which to pose the questions, even if not to answer them definitively. Let me discuss something about human perception of time that I find absolutely fascinating. Our experience of time is not a simple, unmediated perception of objective reality, but is constructed by our brains out of memory, anticipation, and the dynamics of neural processing. Researchers have identified what's called the specious present that I mentioned earlier, the brief window of time, maybe 2 to 3 seconds long typically, that feels like now to us subjectively. Within this window, events feel simultaneous and present together, while outside it, events feel like the past or anticipated future. This specious present is not the same as the physical present at all. The physical present, to the extent it exists, is an instant, a zero duration point in time with no extension. While the specious present is an extended duration, a window of awareness with temporal thickness. What this means is that even our experience of now is a construction by the brain. It's not a direct perception of some objective instant carved into reality, but a synthesis performed by our brains, weaving together inputs that actually arrived at slightly different times into a unified sense of the present moment. Neuroscientists have found specialized time cells in the hippocampus and entorhinal cortex that fire in sequence, tracking the passage of time internally. These neural structures seem to underpin our sense of duration and our ability to situate events in time relative to each other. All of this happens inside our heads as neural processing. The experience of temporal flow, the sense of present becoming past as new moments arise, is a feature of conscious experience in brains, rather than necessarily a feature of external reality itself. In the block universe, this makes perfect sense as an account. If all of spacetime exists as a static structure, then the experience of flow must be generated from within conscious minds at particular locations along their world lines experiencing sequentially. The flow is real as an experience we have, but it doesn't reflect something objective about the external structure itself. This is strange to contemplate and sits uncomfortably with intuition. The most basic feature of our conscious experience, the sense that time passes moment by moment, might not correspond to anything out there in the world at all. It might be an artifact of how our brains process information and construct experience. Strange doesn't mean false, though. As we've learned repeatedly in science, many aspects of reality are strange and counterintuitive. And the block universe, for all its strangeness, offers a coherent picture of how physics and experience might fit together into one framework.